Okay, so we're going to talk about velocity and acceleration. First thing we want to do is set up our notes. Remember, we want our title, velocity and acceleration. Our essential questions go right underneath the title. Main notes go in this section here. The left column is your questions, and your summary goes at the bottom. Our essential questions for today are: what is velocity and what is acceleration? So before we talk about velocity, we talk a little bit more about speed. And what we want to know is instantaneous speed. So that's speed at a given point in an object's motion. Now, before we were just calculating average speed. So that's the speed of an object over its entire motion. Instantaneous speed is basically just a snapshot. So at one point where it's in motion, you're taking almost like a picture, and that's the speed you're going to get. But knowing the speed of an object does not tell you everything about its motion. In order to know more about how something's moving, you need to know the direction in which it's moving. So basically, velocity is speed in a given direction. So if something's moving at 5 meters per second, that would be speed. If it's 5 meters per second toward you, that'd be a velocity. But in order to know the direction in which an object is moving, you also need to have a point of reference. And a point of reference is a place or object used for comparison to determine if something is in motion. So if I used a desk in my room, and I was walking around the room, I would know I'm moving because in relation to that desk, I'm changing my position. If I was standing at that desk, I wouldn't be moving. So the desk in that case would be my point of reference, or the object I use to determine whether I'm moving or not. So why do we need to know velocity? Well, the first one is the weather. We need to know the direction a storm is moving. Now, storms generally move from west to east, or in our case, they come from the south, usually. Sometimes they come from the east, but that's on rare occasions. The last one that we had came from the south. And so if it's moving from south to north, if you're south of the storm, you don't have to worry. But if you're living to the north, where that storm is moving toward, now you have to get ready for the storm. You have to make sure that you're prepared, especially if it's a snowstorm. Another way why we need to know velocity is airplanes. Air traffic controllers need to make sure they know at what speed and what direction the planes are coming from. Otherwise, there could be a crash, and nobody really wants that. So that's why we need to know velocity. Okay, the second thing we need to talk about is called acceleration. And acceleration is the rate at which velocity changes. And so acceleration can refer to three things: increasing speed, decreasing speed, or changing directions. So if something is increasing in speed, or velocity, that's called a positive acceleration. If something's decreasing speed or velocity, that's negative acceleration or deceleration. Now, a lot of people think that negative acceleration means that it's going the other way. It's still moving the same direction, but it's slowing down. So because it's slowing down, you would get a negative acceleration. And then the other one we talk about is changing direction. The speed will stay constant, but the direction will change. So that's also accelerating. So if something starts out going up, and then it hits something and goes to the right, that's acceleration because now it's accelerating to the right, but the speed is the same. And we're going to see that in one of our labs we do in class. So here's how we calculate acceleration. We're going to take our final velocity, which is the velocity at the end of the time, and our initial velocity, which is the velocity at the beginning, and divide that by the time. And our unit for that is meters per second squared. And when we graph acceleration, you're going to see this curved line. Now, some of you actually started making these when we started talking about non-constant speed. But when we graph an acceleration, the line's going to curve. It's going to gain a lot of speed or a lot of distance in a short amount of time. And that differs from our constant speed is, as you notice here, we have our straight, same slope line, that's constant speed. And then our acceleration graph, which is right here, you see the curve. So for your questions and summary, you're going to write 4 questions to help you review the notes. I definitely think you want to look at doing a practice problem. If you need help with that in class, I will help you. We'll probably do a couple in class as well. And then you want to write a 4 to 5 sentence summary that answers the essential questions. And remember, on your questions, you don't want to use the word what. You want to use explain, describe, calculate's a good one if you want to do a practice problem in your notes, or things like that. And that's pretty much it.